Hey guys, so 7.5 and 7.6, we're going to finish up the chapter by learning how to graph parabolas, okay? And we're going to continue on this path when we get to chapter 9. But the first way that we're going to learn how to graph parabolas is in this form, okay? Y minus k equals h times the quantity of a times the quantity of x minus h, can't talk today, squared. Okay, basically that's called vertex form, okay? So it's called vertex form. The reason for that is because it's sneakily going to give us the vertex. But the goal here is to learn how to graph parabolas in this form. Right? So we're going to use this form for this section, and then we're going to learn a different form in the next section. So what we need to be able to do is first be able to break down what the equation of this parabola means. Okay, so you see the equation here. The first thing that you should hopefully notice is that h and k are really important. Okay, so we've got k and h create the vertex. Right? The vertex is going to be the maximum or minimum, right? We're basically where our parabola is going to open up or down, right? So at that point, I want to show you guys really quickly what the most basic parabola looks like. Y equals x squared. Okay, y equals x squared, right? Looks just like this. It starts at the origin, and it's going to open upwards. Okay? In order to graph any parabola, you need to create a table of values. All right, you're pretty much going to use the vertex. Right, so in ours it's 0. That's going to be your middle value. And then you just give 2 values on the left of that and 2 values on the right of that. So -1, -2, and 1, 2. All right, we need to find all the y's. So 0, 0 obviously works. If you plug in 1 or -1 for x, you're going to get 1 for y. And you're going to get 4 if you plug in 2 or -2. So we plot all of those points. You need those 5 points in order to graph these things. Okay, and that's how you graph it. Okay, so it looks just like that. Now, what the vertex does, right, that h and k, when you add an h or a k to this, h is going to slide you left and right. Right, you're actually going to slide the opposite direction that you think, because notice here, it's really important to see that h, okay, is going to be the opposite of what you see in the equation. Right? Because in the formula it's minus h, and in the formula it's minus k. So h and k are actually going to be the opposite of whatever you find in your formula. It's really important. Right? And that's going to slide you left and right and up and down. Now a is going to determine the shape and direction. Okay? So really, firstly, what a does is it's going to, if it's bigger than 1, then the parabola is going to get skinnier. Okay? You might also see this, hear this as vertical stretch or vertical shrink. Right, so the top one, right, when it gets skinnier, it's called a vertical stretch, okay, and when it gets wider, right, if a is less than 1, it's going to be a vertical shrink. Right, so let's do this one in blue, and I'll just graph something that looks like that for these. So a shrink would look like this, right, it's going to get wider, fatter. Right, if you just add an a here, so let's just say we added like 1/4 or something like that right there. It would be like that. And if you added like a 2 instead, right, bigger than 1, it's going to look more like this. Okay, it's going to be stretched, or it's going to get skinnier. Right, if a is negative, then the whole thing's going to flip upside down. Okay, so it'll just start the same way, be the exact same shape, but flip upside down, open upside down. Right, and the last thing is the axis of symmetry. Right, the axis of symmetry is going to be the equation of a line, and the equation of that line is going to be an x equals graph. Remember that x equals graph are vertical lines. Right, where the axis of symmetry is, it's just right at h. So for this one, h is 0, so it's right here. We represent the axis of symmetry with a dotted line. What it does is it cuts your parabola directly in half. Okay, so it's cut in half like that. If you fold it over that line, it would land directly on itself. Okay, let's actually do some graphing. So we're going to graph and state all of those things. Okay, so I'm going to give you, you're going to find domain, range, max, min, and vertex. Okay, so for this first one, right, the easiest thing to do is get the vertex right away. Right, so we'll get the vertex. Remember, it's the opposite of what we see in here. So -3, -2. Okay, -3, -2, that's really important. Now, because of that, obviously the x1 goes here, and the opposite of that, y1 right there. Right, now the max and the min. Now to figure out whether you have a maximum or a minimum, what you need to do is you need to look at a. Right, so a here is non-existent, so it's just 1. right? If A is positive, then you have a minimum, right, because it opens up. If it's negative, you're going to have a maximum because it opens down. So this one is positive, so we have a minimum. And that minimum is just going to be the y value of your vertex. So our minimum here is -2. Right, so we can go ahead and plot our vertex. Go to -3, -2. Plot it on there. Now, to find the domain and the range, right, the domain for all parabolas is just going to be all reals. And I'm going to represent all reals just with basically a capital R with a second vertical line. Okay, that's the way you're going to see it written in pretty much all math classes from here on out. All right, now the range is going to start at your maximum or minimum, okay, and it's going to go on to positive infinity or negative infinity. Okay, so you could just write, y is greater than or equal to -2. All right, what I'm going to do is I'm going to use interval notation. Okay, so a bracket means inclusive, right? So that means we're including -2. If we had a parentheses there, then that would basically mean that -2 right there would be an open circle. But these are all going to be inclusive. Right, so -2, comma, to infinity. Right, and infinity does always have a parentheses. Okay, so that's called interval notation. And to find the zeros. Okay, the zeros are the x-intercepts. Right, in order to find the x-intercepts, all you have to do is set y equal to 0. Okay, because right, x-intercept means it's crossing the x-axis, in which case y would equal 0. So set y equal to 0, and we're just basically finishing completing the square. So I've got x plus 3 squared equals 2. Okay, square root both sides. X plus 3 equals plus or minus root 2. And subtract the 3 over. Okay, so our zeros are -3 plus or minus root 2. Alright, those are the zeros. And then in order to find the y-intercept, you just plug in 0 for x. Right, so that would help us out. If you plug in 0 for x, you're going to get 3 squared is 9, and subtract the 2 over, so you're going to get 7. So the y-intercept here is actually 7, which is helpful to check to make sure our graph is correct. So we're going to go up to 7. Right, and that point should be on our parabola. Now, in order to finish this, remember that the way that you figure out what this graph, the shape looks like, is you have to create a table. All right, so I've got a table of values here. Right, I'm always going to start, the middle one is going to be whatever your, at the x value of your vertex, right, so -3, right, and I'm going to take 2 on the left of that, 2 on the right of that, -4, -5, -2, -1, right, so I already figured out the vertex, the y value of that is -2, now, to plug in, I just need to plug each of these in, and figure out what we're going to get here, so if you plug in -2, you're going to get -1. -4 is also -1. So I can write those in. And if you plug in -1, you're going to get 2. And same for -5. Right? It should always work out like that. It's always going to be very symmetric. Just like this. It looks like our y-intercept does fit in there. And that's your parabola. Okay? So it's a lot of work to get that done. Right? I'm asking for a lot of information here, though, so don't need to worry about it too much. Alright, next problem. We're going to graph this one. Alright, find the vertex right away. It's -1, 3. Right, -1 up 3. This one's going to open down, so it's a maximum. Alright, the maximum, remember, is the y value of that, so it's 3. The range is going to be from -infinity, because it's opening down, up to 3 with our bracket, because it's inclusive. Domain is all reals. And the zeros, we need to solve this. Plug in 0 for y. We've got negative. Well, we can just get rid of that negative on both sides right away. And we've got x plus 1 squared equals 3. Square root both sides. X plus 1 equals plus or minus root 3. And we've got -1 plus or minus root 3. All right, now you could obviously plot those on there. It's kind of hard to do. We can't get the y-intercept, though. The y-intercept is going to be -1 plus 4. Or sorry, -1 plus 3. Okay, it's 2. Okay, and we can go from there. Create our table of values. Right, start with your middle value, the x value of the vertex, -1. Go up 2 from there, down 2 from there. We know already that at -1 we're up at 3. All right, plug in 0 and you're going to get 2. Same for negative 2. If you plug in 1, you're going to get negative 4, negative 1, and same for negative 3. Okay, there's your graph. Looks just like that. All right, a couple more examples here. So we've got, for this one, we've got the vertex, right, is negative 1 for x, but 0 for y, right, because there's no k over there with y. Right, so the a here is 1, so it's going to be a minimum because we're opening up, and it's going to be at 0. Okay, the range is going to be everything bigger than 0, so 0 to infinity. The domain's all reals, and the zeros you could just square both. Well, square root of both sides isn't going to do anything for you. It's just going to be x equals, right, here, look, so we've got 0 equals x plus 1 squared. Square root of both sides does nothing, so we've got x plus 1 equals 0. And subtract that 1. So 0 is just 1, 0 at negative 1. Okay, so we start with our vertex, 0, negative 1, 0. We got to create our table, x, y, negative 1, negative 2, negative 3, 0, 1. This is at 0, 1, 1, 4, 4. Okay, and you can, of course, do this in your calculator, too. Ooh, that's terrible. Sorry about that. All right, the next one. We just need to do a little bit of shifting on this one. All right, so we're going to move the 1 over and the 2x squared over. Okay, so we've got the vertex is 0, 1. It's a maximum because it's a negative a, and a is negative 2. It's at the y value of 1. The range here is going to be going down. So negative infinity to 1. Domain's all reals. Zeros, we're going to plug in. We've got negative 1 equals negative 2x squared. All right, so x squared equals 1/2. And x equals plus or minus root 2 over 2. All right, so we're at 0, 1. We're going to open down. 1, 2, negative 1, negative 2. Okay, now we're going to plug in. We've got, at 1, we're going to have negative 1. And same for there. And for the 2's, we're going to have negative 7's. Okay, so see how it shrinks down, or it stretches down like that. Alright, it gets a little bit skinnier. That's your problem. Alright, number 5, why don't you guys give that a shot on your own. I'm going to show you how to do these last two. Alright, so to find the equation, alright, I'm always going to give you the vertex. Okay, so remember we've got y minus k equals a, x minus h squared. So I give you the vertex. That's going to go in for h and k. These are going to go in for x and y, and I can solve for a. Okay, so I'm going to go ahead and plug those in right now. I've got negative 5 plus 2 equals a times 2 plus 1 squared. So we've got negative 3 equals 9a. Oops, a, not x. And a equals negative 1/3. Okay, so this is y plus 2 equals negative 1/3 x plus 2. Oh, sorry, x plus 1 squared. Okay, you try the last one on your own.